So how exactly does the blockchain work? Well, the first thing that I need to bring up here is the digital money problem. If you think about it, guys, if we have digital money like Bitcoin or Ethereum or Cardano or all of these other cryptos, if I send some of my Cardano, for example, to another person, how do we make sure that I actually sent that money? How do we verify that this transaction was legit? Because instead of fiat, where all these banks and centralized authorities have these ledgers and they say, okay, person A sent money to person B, how do we actually track that when it comes to this digital money aspect? Also, when it comes to tracking this, how do we actually trust the system that is tracking it, especially if there isn't some sort of centralized authority or bank? And then the final part of this digital money problem is how exactly do we govern this system? How do we reach consensus? How do we make sure it's fair? And how do we make sure that everyone that's participating agrees on these different transactions taking place? Now, the blockchain is what solves this digital money problem. And very simply put, a blockchain is simply a distributed ledger where you have all this data of all these different transactions. And this data is in blocks. That's why it's called blockchain, where now all of a sudden each of these blocks have all of these transactions and timestamps, as well as a reference to the previous blocks. So on Bitcoin, for example, each block is 10 minutes. Once a block is solved, it has all of this data of these transactions and timestamps and references. And that data or that block is now on the blockchain forever, which anyone will be able to view. So this is a whole entire ledger system, or almost like an accounting system of where this money is actually going. The next part of a blockchain is you have these nodes, which a lot of times are these expensive computers that validate these different transactions coming in. And then the next part of that is called consensus, which is where we agree whether or not these transactions were actually legit. Different blockchains have different mechanisms to solve for consensus. You might have heard of proof of work before. This is what Bitcoin uses, where you have these powerful ASIC miners, these computers solve these complex puzzles. And then a lot of blockchains are proof of stake, such as Ethereum or Cardano, or pretty much most of the blockchains out there that operate in a different consensus mechanism. One of the most important aspects of this distributed ledger is called cryptographic hashing. And what this prevents is manipulation of these different block datas. Because all of a sudden, if someone tries manipulating one of these blocks or one of these datas, we can easily identify there's tampering. And this is why Bitcoin, all the way since 2009, has never had a single hack or exploit or manipulation of its data literally since inception. And the last part here is actually smart contracts, which open up a world of capabilities with blockchain technology. Bitcoin doesn't have smart contracts, but smart contracts are simply self-executing contracts in code when certain conditions are met. So instead of hoping that someone fulfills some sort of agreement, you can actually have that agreement in code in a smart contract. And simply put, I can have a smart contract such as a marketplace, for example, where I can list one of my NFTs for 1,000 ADA, and I can say, hey, if someone buys or sends me 1,000 ADA, then they'll automatically get this NFT. And what's cool about smart contracts is there's no middle party. It's all executed on code and it's fully verifiable and transparent, but I'll get into that more in the future. Now, how exactly does the blockchain work? Well, there's a couple parts, guys. The first thing that happens is a user initiates some sort of transaction. Hey, I want to send $1,000 worth of Bitcoin to this other user or to this other wallet. And what happens is you have people that can run nodes that help decentralize the network, and they validate that transaction through these different softwares. And once these validated transactions happen, they are grouped into a block of data. That block is then broadcasted to the broader network. And when this happens, this is when the consensus mechanism is so important, where on Bitcoin, for example, you have all these expensive computers verify and legitimize that this block or this data is actually correct. And then once that happens, that transaction transaction is confirmed, that block is confirmed on the blockchain, and now it's immutable. It can never change. So if you ever hear someone say, oh, crypto is used for a bunch of scams and you can't track anything, just know that person has no idea what they're talking about, because every single transaction is recorded on the blockchain forever and no one can manipulate that. And that's why it is one of the best, if not the best use cases of a distributed ledger. One of the things that I wanted to say here is you're probably wondering, okay, why are people helping decentralize the blockchain and having all these expensive computers? What's really awesome is they get rewarded in that blockchain's crypto for helping solve this consensus mechanism. For example, on Bitcoin, if I have an expensive computer that helps solve a puzzle, every single block is rewarded with 3.125 Bitcoin currently, and that reward is split between everyone that helped verify that transaction. So there's an incentive to actually help decentralize the network and to actually offset the cost of all the electricity in the computer components. Different blockchains have different tokens that they reward. For example, on Ethereum, that's proof of stake. If you stake your Ethereum, which I'll get into in a later video, you're going to be able to earn Ethereum rewards. Now, one of the issues with blockchain that you'll hear pretty often is called the Trilema. We want to have decentralization in these blockchains, but we also want to have security and scalability. So when it comes to decentralization, there is no central authority. Whenever you hear decentralization, it means that the power is split between a lot of individuals that are running these different nodes. For example, instead of some sort of central authority like the US government that controls everything when it comes to the US dollar, you then have security, which is avoiding these different hacks and exploits. And then the final part of the Trilema is scalability, which is how fast and how cheap these different transactions are. And each blockchain has a different solution or prioritization of these three different levels. Now, what's interesting, guys, is let's say I want to focus on decentralization. Well, the more nodes you have or the more people helping verify the transactions, the more decentralized it is. But in order to actually get these different computers or to be able to verify these transactions, you have to have computers. And the more powerful the computer is, the more expensive it is. So if you have a computer that's way cheaper, now all of a sudden you can be more decentralized because more people can afford it. But because you now have a cheaper computer, it is now not as scalable or not as fast because those components can't handle transactions as quickly. Now, when we look at security, it costs a lot of computational resources to make sure things are secure. So if you focus too much on security, now all of a sudden your process of the blockchain can slow down a lot. You then have the third process, which is scalability, which is trying to get those faster and cheaper transactions. But once again, the faster you try going, the more expensive the computers, the less computational power you want to use. And because of that, now all of a sudden you have to negate the other two aspects in order to really prioritize scaling. So a lot of times blockchains out there will focus on 2 out of the 3. They might be super fast and secure, such as Solana, but in return, they might give up on some decentralization. Or you might have something like Cardano that's very decentralized and secure, but it's not nearly as scalable. Now, a lot of these blockchains that we see right now are called monolithic blockchains, but there's something new that came out somewhat recently called modular blockchains, which is something I'll cover in a later video that hopes to solve this trilemma issue. Now, in crypto, we actually have different types of blockchains. We have layer 1s and then we have layer 2s. And like I said a little bit earlier, every blockchain is trying to build an ecosystem and prioritize their resources into either scalability or whatever the case is in order to get more people to actually build on that ecosystem. And the reason they want to do this, maybe they have a grandiose reason of having a decentralized currency that we can all trade with. But one of the main reasons is that there is a gas fee when it comes to operating on these different blockchains. So when you operate on Ethereum, for example, your gas, or in order to make a transaction, is in Ethereum. So it costs money to actually use these different blockchains. Now, what's interesting is these blockchains will have different mechanisms for consensus, such as proof of work versus proof of stake, but they'll also have a lot of different variables of why you might want to build on that chain. A lot of the layer 1 blockchains are the main blockchain where everything is happening on that chain. You have the settlement of transactions, you have the execution of transactions, you have the consensus, you have the data availability, a bunch of different things. things. And these are some of your big blockchain names that you know about, such as Bitcoin, Ethereum, Binance Smart Chain, Solana, Cardano, AVAX, or Avalanche. But what's interesting is a lot of times these layer ones aren't scalable enough, and they end up being very expensive where their transactions are either very slow or expensive. And this is where you had a bunch of layer twos come out, such as Polygon Matic, Optimism, Arbitrum, ZK Sync. And what layer twos do is they build on top of the layer one. So most of the time, such as Polygon Matic, for example, you're executing all of these transactions over on the Polygon blockchain. And what happens is they bundle up all of these transactions together and they roll them up almost like a fruit roll up. And this is called a roll up L2. And then they submit that to the layer one. And by doing this, now all of a sudden, by doing all of these transactions over on Polygon, you're able to be faster, you're able to be cheaper, you're able to be way more scalable, and then you simply roll up those transactions and submit it onto Ethereum. And because of this roll-up type architecture, it ends up being a lot less expensive to settle this on Ethereum. And because of that, you still have the security of settling this on Ethereum, but at the same time, a lot of these different transactions were taking place on that L2, and because of that, it was a lot cheaper. Right now, we see a lot of different Ethereum L2s out there simply because of how expensive Ethereum is. And part of Ethereum's scaling plan for the long term is to help these different L2s come together to really solve the scaling solution when it comes to the crypto space. The next thing that I want to quickly bring up here are the use cases, the dApps, and these different blockchain ecosystems. I kind of view blockchains, guys, as software programs. And they're building this software and they're saying, hey, you should build using our software, you should build using our blockchain because we're super fast or we're super scalable or we have a lot of support or we have a lot of users, whatever the case is, right? And I view blockchains very similarly to something like Microsoft, Apple, Google, Samsung, that sort of thing, where it's like, okay, I have this Apple operating system. I can now build different apps that are using that operating system. And then I can now launch on iTunes or at the App Store, whatever the case is. Same thing with Samsung, same thing with Google. They're all trying to do the same thing where they're building out all these apps within their ecosystem, and different projects or different teams can decide to use their software in order to build using that program. It's the same exact thing with blockchains, and a lot of these blockchain developers or teams want projects or teams to build different dApps, decentralized applications on their network. And some of these things could be real world assets, it can be gaming, it can be voting, it can be decentralized infrastructure, it can be IP, supply chain, financial services such as swapping, borrowing, lending, synthetics, you name it, it is on the blockchain. And they're using this different decentralized aspects and applications and smart contracts in order to open up a bunch of use cases that were never possible in the Web 2 setting. And if you hear me say Web 2 or Web 3, Web 3 is pretty much encompassing all of the crypto and blockchain space, and Web 2 is pretty much everything that's not in blockchain. One of the interesting things to note is that these different blockchains will have different compatibility with other blockchains. So for example, EVM is Ethereum. It's built using Solidity as the main coding language, and there are a lot of blockchains that have EVM support. You then have something like Rust, which is on Solana, which has a different way of doing things, and there are pros and cons to each of these different languages, as well as compatibility issues between these different blockchains. So if you ever hear someone talk about interoperability, it's how easily these different blockchains can interact with each other. And if it's EVM chains, for example, such as Arbitrum, it's very easy to interact with other EVM chains, whereas something like Rust, it's not easy to interact with EVM chains. So to kind of summarize everything I said, because this was a pretty in-depth video, blockchains are distributed ledgers with different ways to validate information. That's at its core. It's all about taking this digital money that's moving around and verifying that it's legit and putting it into blocks of data that anyone can look back at. All of these different blockchains operate in different ways, and almost like Apple or Samsung or Google, they're trying to have an ecosystem of decentralized applications built on top of them. Right now, all these blockchains are trying to balance security, decentralization, and scalability, which has led to a lot of different layer 2s rather than just the layer 1s. And blockchains and their dApps open up a realm of possibilities and use cases that are currently not available in Web 2 because of the aspects of smart contracts.